Hello, AP Calculus students of the future. It's Mr. Ford here with another tutorial of your summer packet. Today we're talking about topic G, linear functions, and I am going to put at the top of this one, very important. I'm going to put a big old exclamation point. This is muy importante. This one is a very, 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 very important topic for AP Calculus, and what's really nice for you, it's super easy. But what you'll learn right away in Calc is that a lot of older ideas from, say, your Algebra 1 days or your Algebra 2 or Geometry days get a huge glow up. They become suddenly very important. And probably the weirdest one of those, in my opinion, is point-slope form, which I don't even know if you remember point-slope form from Algebra 1. But point-slope form from Algebra 1 gets a huge, huge, very important center stage spotlight in calculus. So we're going to practice that today. So this is a really important one to run through. The nice thing is it's linear equations. It's mx plus b. It's slope and y-intercept and stuff that you've been doing since you were an 8th grade or freshman. It's very, very, very simple. So none of that stuff has changed. So let's just practice some problems. For number one, we're going to need, for A, B, and C, we're going to need to remember point-slope form. Very important. Point-slope form, I'm going to write it two different ways. The way that I remember being taught it in elementary school, or sorry, probably middle school, high school, the way that we usually teach it in Algebra 1, it looks kind of like that. In this case, m is the slope, and the point is xy. Xy is a point on the line, and all you got to do is plug in the information that you got, and you're pretty much good to go. Now we're going to get a little bit of a glow up, and I'm going to use a calculus notation thing right now that you will not recognize until about October of the class, but the AP Calculus version of this looks like this. It's y minus f of a, since f of a is the function value at some point a. So same thing as y1, just expressed a little differently. The slope is the one you won't recognize. It's f prime of a times x minus a. This is the same thing. In this case, f prime of a is still the slope, and the point is now a f of a. But it's the exact same idea. So with that out of the way, let's go ahead and do some problems. All we really got to do here is write the equation in point-slope form. There is no other challenge here. Now, it might help too if you're kind of a person who struggles with plug and chug. It might help to label your stuff as you go. M is already labeled for us, so this would be y minus negative 7 equals negative 7 times x minus negative 3, like that. And honestly, that's it. You don't even need to convert it into slope-intercept form. I know you want to. You don't have to. You could, of course, make this a little simpler by changing the minus negatives into pluses. There you go. That's it. Let's try another one. How about B? How about y plus 8, going ahead and skipping that minus negative step? Big brain time. Negative 1/2 times x minus 2. That's it. Easy as pie. All you gotta do is plug the right numbers into the right spot. Simple. Oh no, fractions. Oh no, I'm not even scared. Y minus 1/3 equals 2/3 times x plus 6. There you go. Now, could you distribute that 2/3 and make it 2/3 x plus 4, and then add the 1/3 over and make it slope-intercept form? Sure, but you don't have to. One thing we'll talk about a lot in AP Calc, especially preparing for the AP Calc test, is if they give you a thing to do, and here they told you to find the equation in point-slope form, when you've done it, stop. You don't need to go any further. You've done it. You'd be surprised, when we'll look at a lot of examples of AP Calc test answers, you'd be surprised how little you actually have to do on some of these problems. If you just give, like, an equation, as long as it's correct, it's correct. That's it. So you'll be fine. Let's talk about number 2. Here's where things get a little trickier, but still these are Algebra 1 problems. For number 2, you're still going to write the equation in point-slope form. The only challenge here is that I have not given you the slope, so you have to find the slope. Now, I know slope is a Algebra 1 skill that you probably have done many times, but let's just take a minute to remember that slope is nothing more than the rate of change in y over the rate of change in x. Change in y for change in x, sometimes called the rise over the run. And what we'll be doing today is what we call the slope formula. since the change in y can be easily done by doing y2 minus y1 and dividing it by x2 minus x1, like that. So rise over run, that's it. So for question A, we got to find the slope first. We're going to do 2 minus 6 over negative 1 minus negative 3. As we say in Algebra 1, it does not matter what order you subtract in, as long as you are subtracting the y's first. So you can do 6 minus 2 if you want to. As long as you do 6 minus 2, you then have to do negative 3 minus negative 1. You got to follow the same order that you use on top and bottom. I was taught as a drone to go backwards in middle school, so I still do that to this day. This is negative 4 over 2, which is negative 2. So now that you know the slope, the rest of the problem is done the same way. You actually have your choice as to which point you want to use. It does not matter which one you use. They will give you the same answer. I tend to use the one that's got smaller numbers, so I'm going to use negative 1 and 2. This will be y minus 2 equals negative 2 times x plus 1. That's it. Simple. It will be a slightly different equation if you were to use negative 3 and 6, but it gives you the same answer. If you actually expand it out and move it into slope-intercept form, those equations are exactly the same. They don't look the same, but I promise you they are. A good hack, by the way, to know if something is the same is to graph it on your calculator and see if it's the same line. We'll talk about that a lot this year. Question B, kind of the same thing. We had to find the slope first. That's negative 4 minus 1 over 3 minus negative 7. Careful with negatives. They are always going to be a problem for us. Negative 5 on top, 10 on bottom. This is negative 1/2 for the slope. So choosing the second point for x and y, it'd be y plus 4 equals negative 1/2 times x minus 3. There you go. Point, slope, form. Gets a huge glow up. Oh no, fractions. Okay, let's be careful here. So for our slope, we're going to have 1 minus 2/3 over 1/2 minus negative 2. Yeah, another thing you'll find as we get further into this class is that kind of the level of expectation of your fluency and competency with these kind of problems, it continually increases. I'm going to move my webcam onto this monitor. Hang on a minute. Oh no, I can't. The cord's not long enough. I feel like I'm staring at my work on this monitor and the camera's over here. But it's okay. Actually, look, I'm looking at the problem. Okay, this is unimportant. So 1 minus 2/3, for example. It's going to be kind of expected that you recognize that's just 1/3. If you had a whole pizza and you got rid of 2/3, 1/3 is left over. So this is 1/3 on top. Generally, I recommend sticking with fractions, especially in a class where we're not allowed to use a calculator for a lot of it. So fractions are your friend when it comes to non-calculator math. 1/2 minus negative 2 is 1/2 plus 2. So that is 2 and 1/2. And I'm going to write it as a mixed number for now because I can't do a lot of steps in my head one at a time. 2 and 1/2, in order to divide these fractions, I'm going to write that as 5 halves. And when it comes to dividing these fractions, I'm just going to flip and multiply 1/3 times 2 over 5. We're looking at 2 over 15 for our slope. Yeah, that's what it is. So, again, it doesn't really matter which point you choose. I'm going to choose, I guess, this one again. So my equation is y minus 1 equals 2/15 times x minus 1/2. And there you go. You know, if you're going to get used, if you want to try to do one other algebra step on these problems, if you want to, it might be a good idea to get used to. You can add the 1 to both sides. So it'd be y would equal 2/15 times x minus 1/2 plus 1. These are the same. But a lot of the answers that our textbook uses are written in the red form down below, so it might be worth using. It's worth mentioning right now that the AP Calculus test would accept both answers. If this is a free response question on the AP Calc test, if they saw either one of those, they go, all right, you got it. Next point. Okay, for number 3, I'm going to make an edit to this worksheet. By the way, if you're watching this video, we do not talk about normal lines in AP Calculus anymore. We'll mention it in this video what those are, and I'll bring it up in class when it comes up, but any question involving normal lines has been scrapped from the AP test for the last like 6 or 7 years, so we won't be dealing with it in this class. it's not especially difficult. We have to find the equations of the lines through the given points that are parallel. Now here's a key word. You guys remember from geometry maybe that parallel lines have equal slope. So what we need to do is first of all figure out the slope of this line. What is the slope here? And then we're going to use that slope for our line. So that's what we got to do. So x plus y equals 4. Let's think about what is the slope of that line. Well, it'd be a lot easier to know what the slope was if it was in slope-intercept form. So let's subtract the x from both sides. Now that we've done this, we can easily see that the slope is -1. M in this problem is -1 because that's the coefficient of x right there. So since we want a line that's parallel to this line, we have to use the slope of -1 as well. So our line is going to be y plus 3 equals -1 times x minus 5. Or more simply, y is equal to negative x minus 5 minus 3, something like that. It doesn't really matter to what degree you want to clean it up or make it look cool. That's just what it is. So there's that. Now, a word about normal lines. A normal line means perpendicular. My job, as far as being your calculus teacher in high school, my job I consider is kind of twofold. Number one, my priority is to get you prepared for the AP Calc test. That's kind of where I am in my headspace. That's where College Board is. That's where the trend is nationally as far as calculus education goes. However, I do not know what kind of crotchety old math teacher will be coming your way in your college classes. So I will be pointing out things that even though they're not on the AP test anymore, they might be a thing that shows up in your class. Normal lines is one of those things. A normal line is perpendicular. So in this case, we would use, well, this is a bad example, but we'd use the same slope. A perpendicular line has opposite reciprocal slope. So if your original slope is a over b, it becomes negative b over a. Actually, no, it would be positive 1. So we do the exact same problem, but we would use a slope of positive 1. That's the last time I'll mention normal lines in this video. So, same game in B. Let's figure out what the slope is. Let's subtract 5x from both sides. We'll have 2y equals negative 5x plus 7. Then we'll divide everything by 2. And it doesn't really matter what 7 over 2 is. And then we have negative 5 over 2x plus 7 over 2. And this means that our slope that we're going to use is negative 5 over 2. So now that we know the slope and we know the point, let's just go ahead and write our equation. Y minus 2 equals negative 5 halves times x plus 6. That's it. You could add the 2 to both sides if you like. Doesn't matter to me. Now the normal line, I said I wouldn't mention again, normal line would use a slope of 2 over 5. Positive 2 over 5 would be your normal line, but we are not going to do that. Okay, now I won't mention it again. Oh, whoa, whoa, whoa. Oh, interesting. So question C, this is a good one to be aware of too. Y equals negative 2. You might remember this is a special case from your Algebra 1 days. This is a horizontal line. There is no x involved at all. X does not affect the graph at all. So y is negative 2 no matter what x is. So the slope is constant. It's very flat 0. The problem there is that, well, oh, actually, no, it's not a problem at all. It's actually really easy. So m is 0 in this case. So when it comes to writing our equation, I'll pretend that I'm not dense for a minute. It'll be y plus 4 equals 0 times x plus 3. And of course, what's interesting there is that 0 cancels this entire thing out. So we get the equation y plus 4 equals 0, which returns the equation y equals negative 4. And you might recognize that is just the y coordinate right there. A horizontal line can be easily written by just writing y equals whatever the y coordinate is. So y equals negative 4 is fine. As far as the vertical line goes, which is worth mentioning in this case, a perpendicular line to this horizontal would be vertical, and its equation would be x equals negative 3. There we go. See, I said I wouldn't talk about normal lines, and I talked about them 3 times. So there we go. Anyway. Let's go to the next question. Find the equation of the line in general form. I don't wonder what general form means. Interesting. containing the point 4, -2, and parallel to the line containing the points -1, 4, and 2, 3. Okay, this is about as hard as we can make these. I suppose general form, if I'm guessing what that means, is probably what I think is called standard form, which is the form ax plus by equals c. We'll deal with that near the end of this problem. First thing we are given the point, so we have an xy that we're going to use, but we need it to be parallel to the line that contains those 2 points. So let's find the slope between those 2 points, and we'll use that as the slope of our line. That'll be the first challenge. So we're looking for the slope, which would in this case be 3 minus 4 over 2 minus -1. 3 minus 4 is -1. 2 plus 1 is 3, and so our slope is -1/3. Just a quick note, you can write negative fractions either of those 2 ways. They are pretty much used interchangeably these days. So we are going to use that slope for our line because that's the slope that we have. So let's go for it. We use m is -1/3. We have our 2 points up here, so we have y plus 2 equals -1/3 times x minus 4. And our objective now is to write this in some sort of other form. We should be able to algebraically manipulate things like this. So away we go. We're just going to do a little bit of algebraic manipulation, a few kind of steps, and this will be a good chance to practice some of our basic understanding of equations. So let's leave y plus 2 alone for now. Let's just distribute that -1/3. It'll be -1/3 x plus 4/3. And since I want this to be in general form, I'm going to use a trick that we teach Algebra 1 students a lot. I'm just going to multiply everything in this equation by 3. And what that will do is it'll clear out all the fractions. It'll up some of the other numbers, but it will not leave us with no fractions at all. And then we can easily gather x and y on the left side and all the numbers on the right side and be done. So it'll be 3y plus 6 equals -x plus 4. Again, the 3 just cancels out the fractions on the right. So 3 1/3 go away, 3 4/3 goes away, leaving just the tops of those fractions. So the only thing left to do here is kind of do 2 algebra steps at once. We're going to subtract 6 from both sides and also add x to both sides. I'm going to kind of flip those tiles. If you remember your algebra tile days from Algebra 1, I remember those fun times we had. Anyway, we're going to have 3y plus x equals -2. I like that for the answer. Or x plus 3y. Doesn't really matter. And then let's talk about question 5. Question 5 is a very AP calculus kind of question. These are the kind of questions that show up. These are on SAT questions these days too. And they usually throw students for a loop. They're usually very simple if you understand what they're asking, but it's a bit of a stretch sometimes. Find k if the lines 3x minus 5y equals 9 and 2x plus ky equals 11 are parallel and perpendicular. We will not be dealing with perpendicular in this video, but we will deal with parallel. Well, if they're parallel, let's think about this from a puzzle solving perspective. If they're parallel, they must have equal slope. So what we're going to do is we're going to express the slope of both equations, and we're going to set those slopes equal to each other and hopefully solve for k. K is a stand-in for a constant that we don't know yet. So we're going to treat it like any other number as far as we can algebraically. But let's start with the easy part. Let's start with 3x minus 5y equals 9, which I'm going to rewrite over here. And let's figure out what the slope of this line is. And we'll do that by rewriting it in slope-intercept form. We'll subtract the 3x from both sides. That gives us -5y equals -3x plus 9. And then we will divide -5. We don't necessarily need to worry about the 9 so much. It doesn't really matter. We really only care about what the coefficient of x will be, which it looks like is 3/5. Now that is the slope of the first line, indebatably. We must do that. So the real target, that's kind of the target now. The question is, what's the slope of the second line, and what would k have to be in order to get the slope of the second line to be 3/5? So let's start with the second line. Remember, k is just a stand-in for some number we don't know yet. And so we're going to treat it like any other number. So Let's figure out what the slope of this line is by, again, writing it in slope-intercept form. We'll start by subtracting 2x from both sides, which leaves us with k times y equals negative 2x plus 11. And then, just like in the last problem, we're just going to divide by k on both sides. So the k would cancel out over here, whatever it is, and we're left with y equals negative 2 over k x plus 11 over k. Remember, it doesn't really matter what 11 over k is. We really only care about the slope. So that is the slope of this equation. M equals negative 2 over k. And remember, the challenge here is to figure out what would k have to be for these lines to be parallel. So for these lines to be parallel, we need those two slopes to be the same. So that kind of opens up a simpler, smaller algebra problem inside of this one. 3 over 5 equals negative 2 over what number? That's kind of the question that we got to answer. 3 over 5 equals negative 2 times what? So there's a lot of different ways to solve this. You could multiply things, reason out things, draw fraction strips if you want to go to middle school. You know, whatever you want to do. I'm going to use the classic cross multiplication method that I learned as a middle school student. Negative 10 is 5 times negative 2, and 3k is 3 times k. And if I divide the 3 on both sides, I get my answer. K has to be negative 10 over 3. That's what I think the answer is. And that's as far as we're going to go. We don't really need to worry about perpendicular lines, although perpendicular lines would be the same problem. If you wanted to solve the perpendicular lines and go for fun extra credit and be a really cool person, negative 2 over k would be the same thing on the right side. But on the left, instead of thinking about 3 over 5, you would think about negative 5 over 3. It'd be the exact same problem after that. So perpendicular lines just have that opposite reciprocal thing going on. Okay, cool. Again, this one, I'm going to zoom out again and remind you that this topic is very, very important. We do a lot of writing equations of lines in calculus. You'd be surprised how much Algebra 1 stuff we do inside of bigger problems that have bigger ideas going on. But if you can master the slope and y-intercept and writing equations, this one you're going to be A-okay on. So, hey, congratulations on making it to the end of another one of these videos. I am very excited to work with you in the fall. Really excited about where the class is headed, and I can't wait to meet you, work with you. Really proud of you for signing up in the first place. So, and I'm proud of you for making it through this video. You're great. Have a great summer. Go outside. Do something fun. I'll see you in the next video.